80% of people watching this right now are making their eyes weaker every single day. Not from screens, not from bad lighting, from what they're eating. And the worst part? The damage starts years before you ever notice it. Your eyes are the most metabolically active tissue in your body. Ounce for ounce, they burn more energy, demand more oxygen, and require more nutritional support than your heart does. Yet they're the last organ most people think about at the dinner table. The macula, a patch of tissue barely 5 millimeters across, is responsible for everything you use to read a face, drive a car, or recognize your grandchildren. Lose it, and central vision goes dark while peripheral sight remains. That is age-related macular degeneration. It is the leading cause of permanent vision loss in adults over 50 worldwide. Here is the thing doctors don't say loudly enough. Macular degeneration is not inevitable. Cataracts are not inevitable. Glaucoma progression is not inevitable. Nutrient deficiencies don't just accelerate these conditions. In many cases, they are the trigger. Remove the deficiency and you change the trajectory. Studies from the age-related eye disease study, AREDS and AREDS2, the most comprehensive eye nutrition trials ever conducted, confirmed that targeted nutritional intervention can reduce the risk of advanced macular degeneration by up to 25%. That number is not a rounding error. That's 1 in 4 people who don't go blind. But here's the part the AREDS study couldn't fully explain. Why some patients who took the same supplements showed dramatic improvement while others saw almost none. The answer has everything to do with one food most people already have in their kitchen, and almost nobody eats correctly. We'll get to that. But first, you need to understand what's actually happening inside your eye right now. To begin, take a moment to subscribe, like, comment, and share this video with someone who has been struggling with eye issues. Now, inside the macula, your body concentrates 2 pigments at levels found nowhere else in the human body, lutein and zeaxanthin. They are yellow-orange carotenoids, and they function as your eye's internal sunscreen, absorbing damaging high-energy blue light before it can reach and oxidize your photoreceptor cells. Without them, every photon of light that hits your retina does a little more damage than it should. The human body cannot manufacture lutein or zeaxanthin. Not one molecule. Every unit of macular pigment you carry right now came exclusively from your food. And here's the clinical reality. The majority of adults in developed countries have macular pigment levels dangerously below the threshold associated with protection. Kale is the single most lutein-dense food on the planet. 1 cooked cup delivers roughly 20 milligrams of lutein, which is 10 times the amount in a raw cup of the same vegetable. Cooking matters enormously here. Heat breaks the plant cell walls and releases carotenoids that would otherwise pass straight through you unabsorbed. Eggs may actually outperform leafy greens in terms of bioavailability. Not because they contain more lutein, but because egg yolk is a fat matrix, and lutein is fat-soluble. Your gut absorbs lutein from egg yolk at 3 to 4 times the rate it absorbs lutein from spinach. The form the nutrient arrives in is just as important as the amount. Before we go further, take 30 seconds and think about the last time you ate something orange or dark green. Not a supplement, not a smoothie mix, an actual whole food. If you can't remember, That's the data point that matters most in this conversation. The daily target for lutein that research associates with meaningful macular protection is 10 milligrams. To put that in real food terms, one egg gives you roughly half a milligram. A cup of cooked kale gives you 20. A cup of cooked spinach gives you 12. One medium orange, about 0.2 of a milligram. The math tells you clearly which foods need to carry the weight. We just covered what the macula needs to stay alive. Now here's a completely different but equally destructive way eyes can fail. And it starts not at the back of the eye, but at the very surface. In a film of fluid so thin it's measured in microns. Most people in their 50s are already losing it. Dry eye disease affects an estimated 344 million people globally, and the prevalence doubles after age 50. The outer lipid layer of the tear film, the layer that prevents evaporation, is produced by glands in your eyelids called Meibomian glands. Those glands run on one primary raw material, omega-3 fatty acids. When your diet is deficient in omega-3, the glands secrete poor quality oil, the lipid layer thins, and the tear film collapses dozens of times per minute. The most powerful omega-3 fatty acids for eye health are EPA and DHA, not ALA, which is found in flaxseed and walnuts. ALA conversion to the active forms in the human body is less than 10% in most adults and can drop as low as 4% in older individuals. This is not a small distinction. It's the difference between eating for your eyes and thinking you're eating for your eyes. Cold water fatty fish, wild-caught salmon, mackerel, sardines, anchovies, herring are the most concentrated dietary sources of EPA and DHA on Earth. 2 to 3 servings per week delivers approximately the DHA load associated with meaningful Meibomian gland support in clinical trials. Sardines from a can, by the way, are just as effective as fresh salmon. Cost is not an excuse here. What we've covered so far, lutein, zeaxanthin, omega-3s, are the foundations. But there are 3 more nutrients that researchers now believe may be just as critical. And one of them is almost certainly something you've been consuming in a form your body cannot use. We're going to break that down in the next few minutes. Stay with this. Vitamin A is the raw material for rhodopsin, the photosensitive pigment that powers your rod cells, the photoreceptors responsible for low light and peripheral vision. Without adequate vitamin A, rhodopsin cannot regenerate after exposure to light, and the result is night blindness. Difficulty seeing in dim light, slow, dark adaptation, the inability to read a menu in a restaurant without using your phone's flashlight. Most people dismiss these symptoms as aging. They're not aging. They're deficiency. The preformed vitamin A that your eye can use directly is found in animal liver, eggs, and full-fat dairy. Beta-carotene from orange and yellow vegetables is the precursor. Your body must convert it. The conversion rate in healthy adults averages around 12-1. In people with gut inflammation, thyroid dysfunction, or poor fat absorption, which describes a large fraction of older adults, that conversion can fall to nearly 0. Zinc is the mineral that escorts vitamin A from the liver into the bloodstream. Without zinc, vitamin A stays stored, sequestered in hepatic tissue, inaccessible to the eye. This pairing is one of the most overlooked relationships in eye nutrition. You can have adequate vitamin A status and still be functionally deficient in the tissue that needs it most, simply because your zinc is low. Oysters contain more zinc per serving than any food on Earth. A single oyster provides roughly 5 milligrams against a daily requirement of 8 to 11 milligrams. Beef, pumpkin seeds, and legumes follow in that order. If you are vegetarian or vegan, know that phytates in plant foods bind zinc and reduce absorption. Soaking or sprouting legumes and seeds before eating them meaningfully improves the zinc you actually get. We have one more food to cover, and it is the one that surprised researchers the most, because it works through a mechanism nobody was looking for. It doesn't feed the retina. It doesn't filter light. It does something to the blood vessels inside your eye that may be the single most powerful dietary intervention for long-term eye pressure and glaucoma risk. Most people have never heard this connection. You're about to. Glaucoma is not simply high eye pressure. That's the outdated model. Current research shows that impaired blood flow to the optic nerve is an independent risk factor, which means even people with normal intraocular pressure can develop glaucomatous damage if circulation to the optic nerve is compromised. The question is, can diet affect optic nerve blood flow? The answer, it turns out, is yes. And the mechanism runs through dietary nitrates and nitric oxide. Dietary nitrates, found in highest concentration in beetroot, leafy greens like arugula and Swiss chard, are converted by oral bacteria into nitrite, then into nitric oxide in the blood. Nitric oxide is a vasodilator. It relaxes the walls of blood vessels and increases blood flow. Research published in JAMA Ophthalmology found that participants with the highest dietary nitrate intake had a 50% lower risk of early-onset open-angle glaucoma compared to those with the lowest intake. Beetroot juice is now being studied in clinical trials, specifically for its effect on intraocular pressure. Early data shows blood pressure reductions within hours of consumption and a meaningful decrease in intraocular pressure readings in some glaucoma patients. 100 milliliters of concentrated beet juice, that's less than half a cup, delivers a clinically relevant nitrate dose, readily available, inexpensive, and backed by real science. There's a critical caveat here. Mouthwash destroys the oral bacteria that convert nitrate to nitrite. If you are using antibacterial mouthwash twice a day, and then drinking beet juice hoping to support your eyes, you are largely wasting the beet juice. The oral microbiome is the first step in the nitrate to nitric oxide conversion pathway, and wiping it out with chlorhexidine mouthwash eliminates the benefit. Why some patients who took the same supplements improved dramatically, while others saw almost no benefit. Researchers eventually traced it to baseline dietary quality. Patients who came into the trial already eating carotenoid-rich foods had substantially higher baseline macular pigment levels, and the supplements built on an existing foundation. The ones who saw little effect were starting from near zero, and even high-dose supplements couldn't fully compensate for decades of absence. Supplements extend a good diet. They cannot replace one. Here's what all of this means in one clear picture. Your eyes are under continuous biological stress, from light, from aging, from the inflammatory environment most modern diets create. They have specific, documented nutritional requirements. lutein and zeaxanthin to absorb the light that would otherwise oxidize your macula, EPA and DHA to maintain the tear film that keeps your corneal surface intact. Vitamin A and zinc working as a team to regenerate the photopigment your rod cells depend on, and dietary nitrates to protect the blood flow feeding your optic nerve. These are not theoretical benefits. They are the outcomes of some of the most rigorous nutritional research in modern medicine. The damage that is happening to most people's eyes right now has been accumulating quietly for years. The good news is that the biology is largely reversible in the early and middle stages. Macular pigment density increases within weeks of consistent carotenoid intake. Tear film quality responds to omega-3 repletion within 4 to 12 weeks. The eye is remarkably responsive when given what it actually needs. You don't have to wait for symptoms. The best time to change this was 20 years ago. The second best time is your next meal. If this changed the way you see your next meal, share it. Not with everyone, with one specific person, someone whose eyesight you care about, someone over 50, someone who has been complaining about dry eyes or dim light or blurry reading. That one share may matter more than you know.